In this video, we'll be trying to solve some questions on AC circuits in physics. Okay. All right. So this is a continuation from our previous class. This question here says a circuit consists of a resistor 200 ohms and a capacitor of 8 microfarad connected in series. If an alternating voltage of 14 volts and a frequency 60 Hz is applied across the series circuit, calculate I, the capacitor reactance, II, the circuit current, III, the capacitor voltage. Now, there's a B part of the question. The B part says, if the capacitor is replaced with an inductor of 260 millihenry, okay, this is millihenry, calculate the impedance and voltage across the inductor. All right, so how do we solve this question here? Now, for this question here, let's get the solution of this question. Or solution. Let's see how we can solve this question. So solution there. Now for the solution, as usual, our first task would be to list out the given parameters. Okay. So in this question, what and what are we given? That's the question here. In this question, what and what are we given? Now, if you look at the question here says a circuit consists of a resistor. The first I'm giving the number one is the resistance. Okay, I'm giving the resistance there, which is R. Okay, I'm giving R as being equal to, they said 200 ohms. That's 200. The symbol for ohms is this. That's 200 ohms. The second thing I'm giving there, they said, and a capacitor of 8 microfarad. So you're giving the capacitor. Okay, the capacitor, the symbol there is C, is equal to 8 microfarad. Now if I write this out, this becomes 8. The value of micro, okay, micro simply means times 10 to the power minus 6. Okay, so that's microfarad. Next up, they said of course, they said in series. Please note that this must be connected in series. Okay, when it comes to AC circuit concept, they have to be connected in series. I discussed this in our main class. Right, I've already done a full video on the concept of AC and everything you need to know about AC circuit. Okay, if you missed that class, I'll leave a link to that video in the video description. All right, so check the video description. You see a link to our class on AC circuit after this. Okay. All right, next one says if an alternating voltage of 12 volts, okay, or 14 volts, please. So by 3, you're given the voltage V as being equal to 14 volts. Okay. They said, and frequency of 60 hertz. So the frequency, which is a small letter f, is equal to 60 hertz. You're given this. They said is applied across the series circuit. Calculate number 1, the capacitor reactance. So let's get the I part. We have to find capacitor reactance. All right, capacitor reactance. All right. Now, when it comes to finding capacitor reactance, the first thing to notice is that a reactance is simply the opposition to the flow of current in the capacitor. We already explained this in our previous class, which I say I will link in the video description. But then what to notice is that the capacitor reactance is abbreviated by XC. All right. So XC simply means capacitor reactance. And just as we said in our previous class, the formula for the capacitor reactance is actually 1 all over 2 pi Fc. All right. This is the formula to calculate the capacitor reactance. If I should bring in values, this will be equal to 1. All right. This, okay. Let me get my all over yet. So all over, I have 1 into 2. So you have 2 into pi. So you can punch pi with a calculator, or you can simply punch 22 over 7, right? F, what's the value of F? The frequency there is 60. So the frequency there, F, is 60. Okay. Into the capacitance, C. The value of the capacitance was 8 microfarad. That's 8 times 10 to the power minus 6. That's equal to 8 times 10 to the power minus 6. So we have this value. All right, so I'll just get my calculator and punch this answer quickly. All right, so the what I have here is simply 1 all over 2 times pi times f, that's 60, times 8 times 10 to the power minus 6. So if I punch this with my calculator, the value I have here is simply equal to 331 point approximately 57. Right, so this is my value approximately, and this would also be in ohms. I've said that capacitance, or so what you have here, the reactance is simply the opposition to the flow of current in the capacitor. So opposition to current is the same thing as resistance, which is in ohms. So I have my answer here as 331.5257 ohms approximately. That's the first thing here. The second thing I have there, II there, we also have to find what there. Let's see. II say we should find the circuit current. Let's find circuit current. Circuit current. Circuit current. Now, when it comes to finding circuit current, what's your formula for circuit current? Now, here's what to note. There's a difference between having capacitor reactance and then circuit. Now, before you find circuit current, the first thing you have to look out for is this. In the first thing here, the first question here, they mentioned capacitor specifically, and that's why we had to use this formula we used here, right? We're using this formula here because they laid emphasis on the particular element, which is capacitor. In this other question here, they now said a circuit. The question now becomes, what kind of circuit do we have here? All right. In the last class, we discussed that there are three key elements of an AC circuit: the resistor, the inductor that's there, and then the capacitor. Right. So you have this. If I look at this here, you can see that we can find resistor here. That's R. Okay. We can also find capacitor here. That's C. There is no inductor. In essence, this circuit here is an RC circuit. Okay. If you missed out a previous class where I explained the concept of RC circuit, please make sure you check the video description so you can see the link to our previous class on RC circuit. But the concept here is that this circuit here contains majorly the resistor and capacitor. There's no inductor for now. So if it comes to this, how do we find our current? To find a current in this case, you have that V is equal to, from Ohm's law, IZ. Okay, that's a formula. V is equal to IZ. What's Z? Z is called the impedance. Okay, that's what Z is. Z is called the impedance. And Z for an RC, that's for a resistor and capacitor circuit, is given by Z is equal to the square root of R squared plus XC squared. All right, this is the value. This is the formula for calculating the value of Z. And if you have to find current from here, we can, from this formula here, we can see that I will be equal to V over Z. It's just simply divide here by Z, divided by Z. This cancels this. You can see that I is equal to V over Z. Now the thing here is that we already have the value for V. We already have the value for V, the voltage. This, I think it was given in the question there. Let me check. Yep, we have the value as 14, but we don't have the value for Z. So our task will now be, first of all, find Z first before we can find I. How do we get Z? We've already given the formulas: root, square root of R squared. What's the value of R from this question here? From here, R is 200. So root R is 200. That becomes 200 squared plus XC. Luckily, we found the value of XC as being equal to 331.57. So it becomes 331.57 all squared. I have this. All right, so just go through to punching this. From here, Z will be equal to, so if you take your square root, there becomes the square root of 200 squared, square root of 200 squared plus 331.57 squared. And if you do this, if you punch this correctly, your answer should give you 387. That's 387.22 approximately. All right. Impedance is also the opposition to current, so it's also in ohms. Okay. So I have this as 387.22 ohms. All right, approximately. This is the value of the impedance of the circuit. But we're not asked to find the circuit impedance. We asked to find the circuit current. So recall from Ohm's law that V is equal to IZ, as I said earlier. And to get the value of I, I'll divide here by Z, divide here by Z, this cancels this. So I is equal to V all over Z. Let's put in values and punch this. What's the value of V, the voltage? From this question here, the value of the voltage V is 14. That becomes 14 volts. So I have 14. V is 14, so it becomes 14 all over Z. What's the value of Z? We just got Z as 387.22. That becomes 387.22. All right, let's punch this. So I'm having 14 all over 387.22. That gives you about 0.036. Okay, you're having 0.036 as your answer. From here, I'm having this as 0.036. 0.036. Let me approximate this, becomes 62 in amperes. So you have this. All right, so if I approximate this, you have 0.0362 amperes. Now let's use a prefix for this. To use a prefix for this, we simply move this 3 times from here. 1, 2, 3. So I'm having this. So it becomes equal to, that becomes, observe that the dot is between 6 and 2. That becomes this and this before the dot. That becomes 36. So 36. The dot appears between 6 and 2, as you can see here. It becomes 36.2. I move 3 times, so it becomes a milli, small m, then amperes. I have a. So my answer is 36.2 milliamperes. So with this, I've gotten the value of the circuit current. After circuit current, what next? Next we are asked to find is the capacitor voltage. Emphasis on capacitor. So observe that the question moved from capacitor to circuit and now back to capacitor. All right, so understand how this thing works. Okay, so back to capacitor now. For capacitor voltage, okay, in this case, capacitor voltage. To get capacitor voltage, let's call this III. III, capacitor voltage, capacitor voltage. How do we get capacitor voltage from here? Now recall that voltage from Ohm's law, V is equal to what there? IR. This is Ohm's law. But when it comes to a capacitor, the R you have there is what is called the reactance, which is what there? I. Instead of R, you now have what there? XC. That's it. All right. So the capacitor voltage, let me put C here. C here means capacitor, V means voltage. So VC means the voltage of the capacitor or the capacitor voltage. So VC is equal to IXC. And that's equal to, what's the value of I? Now we got the value of I. This is the milliampere. Let's take the decimal value. The decimal value was 0.0362. So I is 0.0362. That's I. Let's get XC. XC, that's the reactance of the capacitor. Okay, XC 331.57. Okay, let's get this. 331 to 331.57. I have this. So VC is equal to, let's punch this, 0.0362 multiplied by 331.57. This is about 12.00. So literally 12.0, that's 12. Now V is voltage, and voltage is measured in volts. So I have 12.002, which is approximately 12 volts. So the answer to this question is 12 volts. Hence, the capacitor voltage is about 12 volts. That's the answer to this question. Okay. All right. I think this is for the A parts. Let's look at the B parts there. Here's the B part. The B part says if the capacitor is replaced with an inductor. Now see what I was saying. I said a normal AC circuit should have a resistor, a capacitor, and an inductor. That's usually an L though. So I have this. Now they are saying, what if they replace the capacitor here with an inductor? That's the concept here. So what happens here? What are we asked to find? If they said if the capacitor is replaced with an inductor of 260 millihenry. So first thing I'm giving here is inductance I. Okay, so inductance is usually L. Okay, that's L. The inductance here is 260 millihenry. So 260, M is milli, H is Henry. Okay. Now, how to tell between milli and mega? If you have MH, capital M, what you have here is mega Henry, and that's 10 to the power what there? 6 Henry. That's it. While if you have small m and H, it's millihenry, and that's 10 to the power minus 3 Henry. Okay. So you can take note of these two things. Now proceeding, I'm giving a millihenry here, and that's equal to 260 times millis 10 to the power minus 3 Henry. So I have this millihenry. You ask to calculate the impedance, okay, and the voltage across the inductor. Difference between impedance and reactance is that if I'm asked to find reactance, that would be XL. This is a reactance, and this is equal to 2 pi FL. This is reactance. If I'm asked to find impedance, that becomes Z. So it becomes Z is equal to the square root of R squared plus XL squared. So this is the formula for finding the impedance of the circuit. Do I have the value of R? Yes, because it's still the same circuit, and the R as given there was 200, but we do not have the value of XL. So my task here will be to find the value of XL. What's XL? I've said that XL is simply the reactance of the inductor, and the formula is simply 2 pi FL. So my first task is to find the value of this XL so that I can substitute it into this equation and get the value of the impedance. That's the concept. All right, so if you have 2 pi FL, that becomes 2 pi times the frequency. What's the frequency value? 60 hertz. 2 pi times frequency is 60. Then L, the inductance, is given as 260 millihenry. That's 260 times 10 to the power minus 3. 260 millihenry. So you have this. All right, from here, we have that XL is equal to, let's multiply this. This is simply 2 times pi times 60 times 260 times 10 to the power minus 3. All right, if you punch this correctly, your answer, just like mine, should give you about 98.02 approximately, 98.02 ohms. So you should have this as your answer, 98.02 ohms. That's your answer. Okay, so you've gotten this as the reactance of the inductor circuit. Okay, what's the next thing here? Your next task is now to find the impedance as you asked to. So the impedance then, Z, is simply equal to the square root of R squared plus XL squared. Now from this will be equal to the square root of, excuse me, that becomes the square root of, let's start with R squared. What's R? The value of R as given here is 200 ohms. You can see it here, right? That's this point here, 200 ohms. So it becomes R is now 200 ohms. So R squared becomes 200 squared plus, let's get XL squared. What's XL? XL is 98.02. So XL 98.02 squared. So I have this. With this now we'll have that Z is equal to, let's punch this and see what we have. The square root of 200 squared plus 98.02 all squared. If you punch this correctly, your value should be equal to 222, that's 222 points, approximately 73 in ohms. Okay, impedance is measured in ohms as we said earlier. So we have the value here as 222.73 ohms approximately. So we've got to the value of the impedance. We also have to find voltage across the inductor. Okay, we also have to find voltage across the inductor. Now, how do we get voltage? Voltage, as we know, V is equal to, since they said across the inductor, all right, it becomes I. For the inductor, it becomes XL. So I have IXL because they mentioned inductor. So I'll use the reactance of the inductor instead. All right, so if we have this formula here, what do we have and what do we not have? We already have the value of XL, don't we? Yeah, we do. We have the value of XL here, but we do not have the value of I, do we? The I we had was for the part A. Now we have to get the value of I for part B. So how do we get the value of I for part B? Now to get the value of I for part B, we'll get the current across the circuit. Now current or V, now to get a current here, recall that from Ohm's law, V voltage is equal to IR. Recalling that in this question here, the capacitor was changed to inductor and becomes the impedance of the inductor circuit. All right, that's the resistor inductor circuit. So I have this. In essence, the current in this question, is equal to the voltage of the circuit all over the impedance. So we'll do this. And from here, this is equal to voltage. In the question here, we're given voltage here as equal to 14 volts. You can see here. So it becomes 14. Voltage of 14 volts. That's equal to 14 volts all over. The value of Z as we got is 222.73. That becomes 222.73. The current here is equal to 14 divided by 222.73. If we do this, your answer here is 0.063, 0.63, please. 63 approximately. And this would be in what there? Amperes. So I is equal to 0.063 amperes. So we have this. All right, so we have this as the current. So we can see the voltage across the inductor V is equal to the current, which is 0.063 approximately. That's the current times XL. What's XL? XL simply the reactance across the inductor, which is 98.02, and this times 98.02. 98.02. All right, let's try to multiply this. From here, the voltage across the inductor would be 0.063 multiplied by 98.02, and multiplying this, my value is 6.18. Okay, approximately 6.18 volts. So basically, this becomes the answer to this question. As I said in our previous class, we've already treated this concept in our previous class. Okay, I'll leave the link to a complete tutorial video about AC circuits in the video description. Also, I've prepared over 100 classes for physics, chemistry, mathematics, and other science subjects on my website for JAM and WIRE candidates. To get access to these over 100 classes, simply visit my website www.jonahemmanuel.com/courses, and you see the JAM/WIRE courses. You can also join my channel membership. All right, I'll leave a link in the video description to get exclusive access to some JAM classes. Okay, I'll leave the link in the video description. All right. Okay, guys, so if you enjoyed this video, as usual, hit the like button. All right, so like this video and also leave a comment. Okay, if you enjoyed the class, please leave a comment. All right, tell us you enjoyed the class in the comment section. Also suggest other videos you'd want to see. Don't forget to subscribe to this channel if it's your first time, or if you're yet to subscribe. Do what to subscribe to this channel. And hit the bell icon. Select all so that you get notified whenever we upload a new content. And finally, share this video to your friends so that they can also learn. Thank you and see you in our next class.